So in the last lesson, we really got stuck into trig in terms of working with something called the cast diagram. And we definitely touched on something called reduction formulas. And so just to highlight, we're going to practice that now. Any angle, obtuse or reflex, can be reduced to an acute angle, an angle less than 90, by either converting negative angles to positive angles. So an example of this would be that the sine of minus 30, that is in this quadrant here, and so this would be minus sine 30. But if I said to you the cos of minus 30, this would just be positive cos 30, because in this quadrant cos is positive. So that's an example of changing from a negative to a positive angle using the cos formula there, cast diagram, sorry. Reduce angles greater than 360. So you also have to be comfortable with that. So if I said to you, what is the sine of 300? Well, the sine of 300 would be, that's 180. So 300 would actually be here. And that's 60 away from the nearest horizontal. But in that quadrant, sine is negative. So this would be minus sine 60. Oh, sorry. No, sorry. The one I've just done there is this one. Use the reduction formula. Sorry. So that's what I meant. Give me a thumbs up if you followed what I've done for those first two. Give me a thumbs down if you haven't. Okay, what about this one? Reduce angles greater than 360. So, for example, if I say to you 420, and then I say, what is the sine of 420? Well, to visualize that, 420 is just 360 plus another 60. So I can say, well, this is in quadrant 1, so sine of 420 is actually the same as 360 plus 60. And in this quadrant, this is positive, and so it's just going to become the sine of 60. Because there's 360, you go the whole around, just go a little bit more. And then the last one, you can use code functions. So if I said to you, what is the sine of 280? And I want you to change that to an acute angle, and I want it to be a cos, well, then what I can do is say, what quadrant is that in? Tell me in the chat, what quadrant is the sine of 280 in? Put it in the... So while we're waiting, welcome to Asande, Bukle, Callan, Kogetso, Machadiso, Naledi, Povunzo, Rawe, Reniwe, Siamtanda, Tamia, Tenda, and Usile. So what do we think the sine of 280 is going to be? It's going to be in quadrant 3. No, actually, this is going to be in quadrant 4, because 280 is all the way to here. But if I want to change it to a cos, I'm actually going to go off the nearest vertical axis. So basically, instead of going to the nearest horizontal, I'm looking at this angle, which is 10. And in this quadrant, sine is negative. But if I want to use the vertical axis, it becomes minus cos 10. And that is, you can put this in your calculator. So I want you to type sine of 280 in your calculator. And then I want you to type minus cos 10. And give me a thumbs up if they match. Give me a thumbs down if they don't match. Okay, so those are the strategies that you need. Those are the tools you need to be able to use. Typically, an exam question would look something like this. So for today's first question, you are going to simplify this. It says without a calculator, so you need to memorize these special triangles, but for now, I will help you. But please let the games begin. You go off and solve this, and if you get stuck, I want you to ask me a question. But otherwise, I want you to fly solo on this. What is this going to be? 60, 30, 1, 2, 3. Yeah, you get started, and I'm going to get some water. What should I do next? What should I do next? I think I need to cancel out the sine x's, and then I need to cancel. There's a negative here and a negative there that cancels out. So I've got cos 30 times tan 30. But now I also know that the tan of 30 can be rewritten by an identity as sine of 30 over cos of 30. And now I know I could always think of that as being over 1, and now I can cancel. So now I just need to evaluate the sine of 30. So I go to my triangle and I go, where is O? Well, if 30 is the reference angle, that's going to be the O, that's going to be the H. So the sine of 30 is a half. Give me a score out of 10 for how that first example went, because I need to know how much time to spend on this type of question. So were you a 5 out of 10 there, a 3, a 7, an 8? How did you feel? Where 10 is perfect understanding, 0 is nothing. What is your number right now? Pop your number in the chat and be honest, because I can't see your faces. And so I need your assistance with this. Okay. Keep those numbers coming. For the rest of us, I would like you to try and simplify the green expression. Welcome to Pila. I see you have joined us. Who else? A couple of students have joined us. Oratile, Naledi, welcome. Oketso, it's good to be with all of you today. We are getting our practice for exams done. How is it going so far? Pop your hand up or just type something in the chat if you need some help. What I was doing is I was rewriting some of these angles. Okay, so let me narrate a little bit what I'm doing. So I took 750 and I said 750 is really big. In order to make life more manageable, I'm going to write it as 720 plus 30. Why do you think I chose 720, everyone? Who feels like they understand why I chose 720? Maybe I should have chosen 700. Why did I choose 720? Can anyone help me? Who feels like they know why I chose 720? Well, we want an acute angle, yes. And also remember, what we normally do is we say, well, 360 is one rotation, 720 would be two rotations. So I know that this is really going to be in quadrant 1. Like if you imagine, because I need to know whether or not cos is positive or negative, and because it's in quadrant 1, it's going to be positive cos 30, because 720 is a horizontal. Now, with this one, I wrote it like this so that I could see I'm in quadrant number 4. So 360 minus 45, I'm going to be in quadrant number 4. And in that quadrant, tan is negative, so it'll be negative tan 45. And then I changed this from a negative angle because for cos, if you're in this quadrant, so a negative angle goes here, cos is always positive. So that's why I can get this as cos theta. Now on the bottom, this is going to be in quadrant 4, 360. Oh, let me do this actually. So this quadrant would normally be theta or x. This would be 180 minus theta. This would be 180 plus. This would be 360 minus. And if you go to the axes, this would be 360, 180, 90, 270. Or if you went the other way around, it would be 0, minus 90, minus 180, minus 270, minus 360. Okay, so this is in quadrant 4, so this will be cos theta. This is in quadrant 4, so it'll be minus sine 60. Notice how these things always fall away when I'm using the horizontal. And then over here, I'm going to get, that's in quadrant 2, and sine is positive there, so I get sine of theta. What should I do next, everyone? What's going to be the next step? The two negatives are going to go away, fortunately. What else could I do? Is anybody feeling? Yes, Simtanda got it there. I want to cancel out those two because they're the same. And so what am I left with? I'm left with cos 30 times tan 45 over the sine of 60. Now, there's two ways I could go from here. The one thing is, if you know your co-ratios, you can rewrite sine of 60 as something which will make life easier. Or what you can do is you can also just start going straight into subbing in using special triangles. So the special triangles, unfortunately, I rubbed out. So now I have to rewrite them. But we have this one for the 45s. And then we have 30. That's 1, 2, 3. So you could start taking the numbers straight from here and putting in here. But the other thing to realize is that, in fact, the sine of 60 is the same as the cos of 30, which means I can cancel those out. So now I have the tan of 45, and that's just 1 over 1, which is 1. Give me a score out of 10 now for that example. How did you feel about that example? How do the people of grade 11? I think we still need to do one more, is the feeling that I'm getting. Okay. I can see the numbers. Thank you very much. Keep them coming. I want everyone to try and simplify without a calculator, the blue one. And then we'll move on to a different type of question. And also, I encourage, if you would like to talk to me audibly, asking a question audibly, you're welcome to have. That's one of the nice things about being live. Don't feel like you have to type. Did I leave out the sign? Oh my golly gosh, everyone, I have made a bit of a mistake. No, I didn't leave out the sign. Oh, I did leave out the sign. Anybody else, can you confirm I left out the sign? So this cos, oh, I did leave out the sign. Okay. But then what happens over here? Ah, okay. Well, should I put it back in again? Hey, I better put it back in again. So all that happens now is it's going to become 1 over sine theta, not just 1 anymore. Yo, what happened there? I think maybe I wasn't paying as close attention or trying to do too many things at once. But luckily, you've got my back, so thank you. All right, let's try and do the blue one. Let's do the blue one. Okay. So we have some choices for number 4. There's not going to be just one way of doing this. I'm feeling tempted to use co-ratios, but some of you... Okay, let me ask the audience here. Would you like me to use co-ratios on cos 260, or would you like me to use the normal reduction formula? Tell me in the chat which one you would prefer me to use for number 4. Because I'm thinking, should I use 180 or should I use 270 as the axis that helps me make this smaller? Okay, the audience seems to be saying, oh, this, okay, I'll tell you what, I'm feeling thing today. I will do both. How's about that? So if you use co-ratios, 260 would be in this quadrant. So you would get minus, and because it's a co-ratio, it changes to minus sine 10. If you used the reduction formula, it would be 180 plus 80, and it's in quadrant 3, which is still negative. And so it would be negative, but it would be cos 80. Negative cos 80. Okay, so that is the difference there. If I used co-ratios over here, I wouldn't use co-ratios. I would just use the nearest thing. So this would be negative cos 10. I think all of you would have used this, negative cos 10. So that's for the second line there. On the bottom, we've got a sine 10. So I'm not going to worry about that now. What about the sine of 190? I think most people would go with minus sine 10. So minus sine 10, because I'm using 180 plus 10. And then the cos of 350, I think I'm going to go with, it's quadrant 4, so it's positive cos 10. Okay, what are we going to do now? Well, over here, we're going to knock out that. We're going to knock out those negatives. We're going to knock out that, which leaves me with a minus on the top and a sine 10 on the bottom. Have I left something out? I don't think I have. Give me a thumbs up if you got the same as me there. If I was doing it down here, I would say cos 10, cos 10. Then I would change the cos 80 to minus sine 10. And then I'd still have another minus. So those two minuses would go away. And then on the bottom, I'd have sine 10 times minus sine 10, which then leaves me with that cancelling, which is minus 1 over sine 10. So it's the same thing, basically. All right, let's move on from identity questions. I think if you need to, re-watch this part, but we did a good amount of practice there, and you can see some of the things there. Let's move on to I know we've already done that already. So we're going to start, just before we start this new type of question called identities, be aware that you can use other identities in identity questions. We're just going to do one, and then we're going to take a break. But I think we can squeeze in one identity question before we start this process. So, proving identities. Okay, let us rock and roll with question number 1. I need to prove that this is equal to this. This is the left-hand side, and this is the right-hand side. According to the best way to do these, I normally start with the harder side. Which side should I start with? What side should I start with? I definitely think, and Naledi agrees, so does Pafunzo, so does Tandi, where we start with the left-hand side. So we go sine x, we'll go left-hand side equals sine x times tan x plus cos x. And now our goal is to make it look like the right-hand side. What should my next step be? What should my next step be? Now that I've chosen a side, what tools do you have in your toolkit that you could help me with? I think, Pila, we agree. Naledi, we agree. We're going to change the tan to sine x over cos x. And now we've got this cos x just chilling. And remember, we must keep our eye on the promised land. Where are we going? The promised land is 1 over cos x. Now, because there's only one fraction here and there's two separate things here, what would your next step be? Does anybody have an idea? How can we bring these two things together? Because nothing's canceling out here. So I'm wondering, I'll give you one hint. How do we bring these two together? I suppose I can write this as sine squared x over cos x plus cos x over 1. What should I do to bring them together? I think it's our old friend, the common denominator. I really need this to be cos x. So I multiply that by cos x. But in order for us not to unbalance the universe, I must times it by the same thing on top. Give me a thumbs up if you can follow that. If that idea, that tool, you've seen that somewhere before. Okay, so this is the good news. The good news is that now my denominators are the same. So I've got cos x. And then on the top, I'm going to have sine squared x. And on the top, I'm going to have... Okay, so at least now it's all together. What's my next step? What's my next step going to be? I feel like I've seen this thing before somewhere. Where have we seen sine squared x plus cos squared x before? That's one of the, that's called the square identity, and I'm pretty sure that this is equal to 1. So this would be 1 over cos x. Oh, but oh my goodness, I've got to where I want it to be, because that's what the right-hand side is. So I just say equals right-hand side, and I am good to go. So obviously I made it look very easy because I could see that those steps ahead of time. So I want to highlight the main things I did to get marks. I chose the harder side. I made my very first substitution over here. I then realized that I had two things I needed to add together, and I needed to end up with one thing. So that forced me to use this idea of creating a common denominator. And then once I had that, I used another identity to get me to the end. All right. Give me a score out of 10 for how well you understood that identity question. Thank you, everyone. I can see those numbers coming in. Okay, well, before we go and have our break, I just want to start the next question. So if I look at the next one, What side should I start working with? The left-hand side or the right-hand side? What do you think? It's 7 marks, so it's a bit of a handful, this question, clearly. But let's just start with the little things, because you can get partial marks. I would definitely say you start with the left-hand side. So what I'm going to do is I'm going to say sine x plus tan x in one bracket, and then the other one is sine x over 1 plus cos x. Now, before I even start with that, can you see that there's no fractions on the right-hand side where we're heading? So at some point, this is what I know, I'm going to have to untangle these brackets. But I want to do it in a way that's the easiest for me. But I know I'm going to have to untangle these in order to get to there. Give me a thumbs up if that makes sense to you. Okay, so now we have to make some decisions. What is the first thing? We can't know exactly where to go straight away, but what would be the first thing that you would do on the left-hand side as a step one, maybe just to get a partial mark? What would your very first step be? And then after our first step, we're going to take a break, but let's just try and think about change the 1 plus cos x. I mean, we could do that. I mean, I haven't done this yet, so I don't know exactly what the right answer is yet. There's definitely something we could do. Well, maybe what we could do is actually, you know what? What we could do is we could make this over 1. Because part of my brain was getting confused, like where does this thing get multiplied by? So give me a thumbs up if you understand that I can put this whole thing over 1. Callan, I was thinking change tan x. I was also thinking that. So I was thinking, let's change tan x. But you know what? I think both ways are actually correct. So what I'm going to do is I'm going to try and bring these things together, because essentially that's what I've got over here. So what I'm going to do is I'm going to say sine x plus tan x in brackets times sine x all over 1 plus cos x, because I've multiplied the top and the bottom together. Give me a thumbs up if you're with me so far. Okay, and now all of a sudden, I'm thinking I need to multiply out these. Now, I could have also written this other way around, but basically, because this isn't a bracket, both these things have to be multiplied. So now I'm getting sine squared x plus sine x times tan x over 1 plus cos x. Now that was tricky because the sine x, we're so used to seeing the sine x on this side, which would have been completely fine, but it also works if you multiply from this side. And again, give me a thumbs down if I've lost you there. Give me a thumbs up if you're still with me. Okay. Now for those who I've lost, just think about what's happening here. If I multiply something, if 3 times 4 is the same as 4 times 3, so there's nothing wrong with writing that top line as sine x plus tan x, and then on the bottom having 1 plus cos x. That's exactly the same. So that's where I get my sine squared x, and that's where I get my sine x times tan x. So it's just because it's on the right-hand side. Reniwe, did that help a little bit? Or everyone else who was feeling confused? Is that okay? Fantastic. All right, we're going to come back to this after the break, but we need to take care of our brains. My brain is shouting at me and saying, look, if you don't take care of me, I'm not going to take care of you. So let us stand up and let us just take some nice deep breaths. Get away from your bed or your table. I want you on your feet, and I want you to breathe in and hold. And breathe in. Breathe in. Last one. Breathe in. Okay. Now, oh, I've got a bit of a head spin. What I want you to do next is I want you to join me in standing up. Shake up your arms a little bit. Get them nice and loose. Shake out this arm. Shake out this leg. And then I want you to just roll your shoulders back. And then roll your shoulders forward. And then I want you to put your arms to the side and just do small circles going forward. And then small circles going back. Okay, and then give yourself one last shake just to get nice and loose, none of that tension in your body. Okay, last bit of the warm-up. You all know what's coming. It's just going to be our jumping jacks just to get ourselves the blood pumping so we wake up. And we'll start in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that's all she wrote. Let me know with an emoji. How are you feeling? How are you feeling? Is your heart pumping? Did you not do the exercise and so you're falling asleep? Hit that emoji because I know that I am ready for part 2 because I jumped around. And so my heart is pumping, but my brain is also full of life. Ooh, but my heart is my heart is beating. I'm not gonna lie. Okay, what should I do next? What should I do next for the next one? So I haven't finished number 2. Hey, I still need to get to the green circle. So I agree. We're going to change. So Callan was saying earlier on we should change the tan x. I'm feeling a bit tempted to change the tan x now to sine x over cos x. Is that helpful? Have I made a mistake? Let's have a look. Sine x, no, everything's good there. Sine x times tan x. Okay, so now I do wonder, what can I do to simplify this? Oh, it actually doesn't simplify. It doesn't do much there. Okay. What would be useful now? 1 plus cos x. Okay, well, let's have a quick look. I seem to have, unless there's something obvious that I'm missing, I don't see the tan x, sine x over cos x. Nothing's going to cancel. I still have a sine x. Let's have a quick look. I'm going to pull up the solution just so we don't waste time. Before I go down, I don't want to go down a massive rabbit hole and like take too long on this, but let's have a quick look. I'll pull up the solution here. Okay. So what they did, give me a thumbs up if you can see number 2 here. So you can see the answer over here. Okay, so let's just have a quick look. You know what? I think we would still have got to it the other way, but that is still a tricky one. So on the right-hand side, they replaced the tan x pretty early on, and they just got this one over here. So that part is easy enough. Over here, what we should have done is we should have changed this to sine x over cos x. Then we would have said, look, I need to add them together. So there's an extra step here. So basically, this is over 1. But now I need to, let me even do this over here. So if I have sine x over 1, but I need it to have the same denominator, I need to multiply the top and bottom by cos x. Give me a thumbs up if you understand that. Because all of a sudden, in this part, these are together, right? Like, how did they get together? Well, the reason they got together is I times the top and bottom by cos x. Now I can put them together, and I get sine x cos x plus sine x over cos x. Give me a thumbs up if you understand this whole green part here. Okay, now they do something sneaky in this line. What do they do in the blue line? That is quite sneaky for this type of question. They take out a common factor of sine x. And why do they take out a common factor of sine x? Well, because what's nice about that is now you have these two factors that are the same, so you can cancel them out. But that was hard to see. But now that I've shown it to you, give me a thumbs up if you see that by taking out this, these two things over here are the same. Okay, so what have we got left? Well, we've got left the sine x on the top, and then I've got another sine x over here, and then on the bottom, I've got a cos x. But remember, we worked a little bit with the right-hand side over here. So actually, now what we have is we have that, which is equal. So we know the left-hand side is equal to the right-hand side. That was actually a very tough one. But what it shows you is sometimes you have to work with both sides and then just show that they're equal. And you can do that. Okay. Any questions or comments about number 2 before I move on to another one? Give me a thumbs up if you're ready to move on. Give me a thumbs down if you're not ready to move on. Okay. Let's find some more. Oh, wait. Okay. I was going to do number. I'm not ready to move on. Okay. Should we do one more like this? Let's do number 3. So can you give number 3 a go? Give number 3 a go and see how it goes. I will put the answer up fairly quickly, but I think just a little bit more practice would be helpful. So try and prove that identity over there. I think I would start with the right-hand side. I think that much. Then the question is, what should we do first? And that's where I would like some help from the people of grade 11. Yeah, so this isn't so bad, actually. The step must be, yes. Okay, now, what do we do next? I'm a bit stuck because I need to get here. How are we going to bring these two fractions together? We need to have the same denominators, hey? So in order to make this the same, I'm going to times this and this by cos x. And in order to make this the same, I'm going to times it by 1 plus sine x. And all I'm doing is I'm making the denominator the same by multiplying by the other denominator, or the other, yeah, essentially. So if I do that, I'm going to get a denominator that is the same. So it's going to be cos x 1 plus sine x. Now, what am I going to get on top? Well, cos x times cos x is cos squared x. And then I've also got sine x 1 plus sine x. Okay, I want to give you some more time to try and figure out what comes next. So just say done in the chat when you feel like you're done with number 3. Because it's not done yet, but I think you've done the hardest parts. Okay, now I saw this earlier. What happens when you add those two terms together? When you go cos squared x plus sine squared x, what do you get? You get 1. Ooh, this is looking very good. I suddenly got very excited. Why did I suddenly get so excited? I feel like I got a glimpse of the promised land here. So when I put these two together, I get a 1. And what do you know? On the bottom, I already had a 1 plus sine x. So the reason I got so excited is I realized, well, these can cancel. And so now I have 1 over cos x, which is equal to the left-hand side. And so I'm done. So that actually looked harder than it was. Some of them look easier than they are. Some of them look harder. But you only really know when you get stuck in. Okay, give me a score out of 10 for your knowledge of trig identities. You definitely want to practice more of these, and the past papers will help you with that. But I just want to get a sense of how you're feeling about trig identities, because you will definitely get one trig identity question for about 6 or 7 marks in your exam. Guaranteed. Okay, well, I'll tell you what, in the last bit of tonight, we are going to talk about trig equations. Okay, so we're going to solve some trig equations. And let me find, okay, I'll make one up for you. Let's just do this. Okay, find me the general solution for the cos of x equals 1 over 7. Now, there's a 3-step process. I would like to know what I start with in my 3-step process. What do I have to do first? So we're going to solve for the general solution of this trig equation. What should I do first? I need to find my reference angle. Yep. Step 2, I have to find the correct quadrants. And step 3 is find solution. So what is my reference angle for cos x equals 1 over 7? Can we have confirmation of Pavunzo's 81.79? Thank you, Tandiwe. Thank you, Asanda. So if that's the reference angle, now this cos is 1 over 7. It's small, but it's positive. So where is cos positive? It's positive in those 2 quadrants. And in this quadrant, the angle will have the form of whatever x is, and here it will have the form 360 minus x. So now I'm going to have a solution in quadrant 1 and in quadrant 4. And so I'm going to say x, actually sometimes some teachers will say this is theta and this is 360 minus theta. It just depends on what's going on. But the answer for this, if you're in quadrant 1, it's just going to be 81.79. If you're in quadrant 4, it's going to be 360 minus 81.79. So what's that going to be? What's 360 minus 81.79? Yeah, so it's going to be 278.21. And so if I do that, it's not yet, that's a specific solution. So I've given you, or you have given me, 2 solutions in the domain 0 to 360. But I want to make it a general solution. What do I still need to do? I'm just going to add the part that represents the repeating period of the solution. And because the period of the cos graph in this case is 360, I just add that bit there. So that is a simple general solution to a trig equation. Give me a score out of 10 for how well you understood that example. Okay. I saw some thumbs down. There's some people who understand it. Now, if you don't, I would highly recommend some of the videos I've done in the past on trig equations. It won't take you long because there's a lovely, simple process. But you might need to watch some of the videos on the MathsLive YouTube channel if you're finding this like I'm going too fast in this part. Okay, I'm going to go to another example that's going to be a little bit of an upgrade. So what I'm going to do here is I'm going to focus on this equation over here. And I'm going to write it as tan x minus 1 over 2 equals minus 3. And you need to find the general solution. Now, this feels harder than the previous ones. What do I have to do to get started with this one? Okay, I need to make tan the subject of the formula. Thank you very much, Callan. So you're right. So I'm going to move the 2 across. I'm going to get tan of x minus 1. And this minus 1 is separate to this thing here, is equal to minus 6. And then I'm going to say the tan of x, if I bring it across, that's minus 5. Now, you need to find the general solution for this for me. So there's a 3-step process, but in step 1, when you find the reference angle, there's something that you need to do, which is important. Can anyone tell me when I'm finding the reference angle from this, what do I need to remember? So you don't deal with the negatives now, you deal with the negatives in the second step. So at this stage, all you do is you go shift tan and you put the number in your calculator. What reference angle are you getting for this trig equation? So we are getting 78.7. Okay, step number 2. In what quadrants is tan negative? Because for this equation, tan is -5, and we have to deal with that reality. We cannot ignore it. What quadrants is tan negative in? What quadrants is tan negative in? So tan is negative in quadrants 2 and 4. So in terms of getting my solutions, technically speaking, I should have a solution in quadrant 2 and in quadrant 4. But here again is where tan is a little bit special. It's not wrong to ignore one of these quadrants. And the reason is the period of the tan graph is 180. So if you have a solution in quadrant 2, that solution will repeat itself 180 degrees later in quadrant 4. So essentially it gets gobbled up. So what I generally say to students is just choose the first one and ignore the second one. You can only do this for tan because its period is smaller. So I'm going to ignore this one over here. Now in quadrant 2, what format is it going to be in? It's going to be in 180 minus the reference angle. So we're going to say that x is equal to what? What is x going to be equal to? So it's going to be 180 minus 78.7, which is 101.3. And to be a general solution, I need to add a k times 180 because of the period of the tan graph. And that's what I mean. Like the second solution would have just been adding, making k 1. The second solution I can get straight from this. I just go 101.3 plus 1 times 180, and that will give me 281.3. And that would also be a solution for this equation, but I don't need to write it because it's gobbled up by that. Okay, give me a thumbs up or thumbs down if you got that question. You understood what I was explaining. Okay, fantastic. Now, we're going to finish with a bit of a toughie, but that's going to be the last question for today. So we are going to look at number 3. Number 3 says, I don't want a general solution. I want a specific solution in between that domain. Okay, that's fine. I'm just going to treat it like I would a general solution question anyway, and I'll worry about that at the very end. Okay, so now I have to start solving this equation. What should my first step be? What should my very first step be? Who has some wisdom and knowledge to share with us? Make it 0? I like sort of. Well, I was thinking this 2 seems a bit lost. I think I need to get the thing where the equation is by itself. And so I'm going to bring this across and I'm going to get -2. So if I take away 2 from this, I'm going to get left with 0.537. Thumbs up or thumbs down for that one? Okay, now what we're going to do is we're going to go through our process here. So step 1 was find the reference angle. Now, for the moment, we're just going to ignore the funky stuff going on in here. I don't deny there's something interesting going on in there. But for now, I'm going to trust the process, and I want you to get me a reference angle for this thing over here. Actually, you know what? Let's do this. I'm just thinking, let's make this the reference angle. All we're going to do is we're going to add this. Let's add it now. So when we say reference angle, we are saying what is 2x minus 10 actually equal to? So actually, you know what? I'm running out of time. Okay, let me show you the process here. Because I don't think I'm going to have time to write it all out. Okay. So let's do this together to finish today. We had got to this step over here. If you go shift reference, shift 0 or shift 0.537, give me a thumbs up if you get a reference angle of 57.52. Okay, now, using our method, if cos is positive, what quadrants, so I'm going to do step 2 here, what quadrants is cos positive in? Okay, it's going to be in quadrant 1 and in quadrant 4. So we're going to have a solution for quadrant 1 and for quadrant 4. Okay, now what are we going to do next? Okay, so now what we normally go just x, we're going to say 2x minus 10, because the reference angle had that funky bit, and it's going to be equal to 57.52. But I'm also going to have a k times 360 because of the period of the cos function. Give me a thumbs up if you're with me on that part. Now, I'm ignoring the second one for now. I'm just staying with this one here. Okay, now, I need to solve for x. What do you think the next thing I'm going to do to solve for x is going to be? I think I need to move this 10 to the other side, and I'm going to get 2x is 67.52 plus k times 360. Okay, now we have one more step to go. Okay, what do we need to do to get x all by itself? And there should also be a k as an element of the integers on the end here. And I'm just dealing with one half of the solutions for now. I need to divide both sides by 2. So now we're going to get x is equal to, okay, what are we going to get? 33.76. But you know what happens? We don't just divide this part. We also divide the k times 360, which means we get k times 180, where k is an element of the integers. Do you all understand why when we bring this 2 to the other side, it divides this by 2, but it also divides that by 2? Thumbs up if you understand that. Thumbs down if I've lost you. Okay. Now, remember at the beginning when we said there was one solution in quadrant 1, there was also a solution in quadrant number 4. And in quadrant number 4, the angles don't have the form of the reference angle. They've got the form 360 minus the reference angle. So let's have a quick look at where the 4th quadrant solution would be. All right, what you notice is that if you go 2x minus 10, let me use a different color. Do you notice I go 360 minus the reference angle in blue? Now, notice how in quadrant 4, my solutions have the form 360 minus the reference angle. So all that's happening, maybe I can zoom out for a second, is I'm going to now do my second solution, and it is going to be 2x minus 10 does not equal the reference angle. It's 360 minus the reference angle, which was 57.52. And then I'm also going to have my k times 360. This is a tough question, so if you're freaking out a little bit, I don't mind. Now, 2x minus 10 equals, what's that going to be equal to? Well, that's going to be equal to 312.48 plus k times 360. Give me a thumbs up if you can get to that point. And now what I need to do is I take the 10s to the other side. So I get 2x is equal to 322.48 plus k times 360. There should also be that k that comes down. And then I'm going to divide both sides by 2, and I'm going to get 156.24 plus k times 180. Where's that? Okay, now I have my 2 solutions. That is my quadrant 4 solution. This was my quadrant 1 solution. Everyone, give me a thumbs up if you followed the 2 solutions there. Okay, now, last thing. At the very beginning, it said, I only want solutions between minus 180 and plus 180. So at the very bottom here, you will notice that they take these general solutions and they put in a value of -1 for k there, and the same thing here. And so the final thing is you actually have these solutions, because these solutions fall in the range between -180 and +180. And they're generating them from these general solutions. Okay, that was a toughie to end. What they do is they just used the k values. Let me actually highlight it for you. They used the k value of -1, a k value of 0, and a k value of 1. And those are the numbers they put in here using these 2 general solutions. Okay, everyone. Today's lesson was heavy, but I know that you needed this practice. Don't stress out if that last one was like, whoa, whoa, whoa. You'll be fine. So what are we going to do in the next lesson on Wednesday? We are going to do, I'm going to look at solving trig, basically trig graphs, and I'm also going to look at some harder trig equations,